In this video, part 2 of our video review of the grade 7 practice final test, we are going to start with problem 11. So let's bring our chalkboard in. Okay, so we see this diagram shows this to be a right angle. That means this angle, which is indicated by x minus 20, plus this angle, which is 42, are going to add up to 90 degrees. So let's set up an equation that mirrors this scenario. The fact that there's nothing out in front of that parentheses means we can remove the parentheses with impunity. We can combine the 42 and the minus 20. 42 minus 20 is 22. Plus x equals 90. We have not yet solved for x because we have a neighbor. 22 is being added to x. Or if you're not clear on this, you can always rewrite this as x plus 22 equals 90. And then it's clear to get rid of that neighbor, you subtract 22. We have to do the same thing on the opposite side in order to protect the integrity of that all-important equal sign. Plus 22 and minus 22 cancel out, and you're left with x equals 68 degrees. First choice. Okay, let's see what's next. Okay, now we have another word problem. Again, folks, with this or any word problem, it's about taking the words and translating it to math. Let's see if we can do that. Okay. One week, Joe earned $22 for every lawn he mowed, and he mowed 4 lawns. Okay, so $22 for every lawn, 1 lawn, times 4 lawns. I'm going to put a hidden 1 there. Folks, look what happens to the units lawns. They cancel. The dollars is not canceled. Therefore, he's going to make $88 for mowing those 4 lawns. Again, the importance of using units to figure out what goes where and then canceling them. The reason why we can cancel lawns is because 1 is above and 1 is below, and there's multiplication going on. Okay, now in addition, he earned $12 for each flower bed he planted. Okay, so here we go. $12 for each 1 flower bed. If he earned a total of $160 per week, how many flower beds did he plant? Okay, you see this word, how many flower beds? Whenever you see words like how many or how much, whatever follows is going to be your unknown. So if it says how many flower beds, that's your unknown. So x is going to go with flower beds, because how many flower beds? X flower beds. We don't know the answer to that, so that makes it our unknown. Okay. So what do we know? We know that the total is $160. Okay. So we already know he got $88 for mowing the lawns. Here, the flower beds cancel out, and he's going to have 12x dollars from the flower beds. $12 times x is 12x dollars. So our equation, folks, is going to be this 88 plus this 12x equals this 160. That's our equation right there. Now we're going to solve for x. Okay. Let's get rid of all this. Again, this is the type of problem that you can just go back and rewind it from the beginning if you didn't follow everything. It's the beauty of video. Okay. So folks, how do we approach this? How do we solve for x? Again, if it's helpful to you, you can rearrange this. In fact, let me do that. You can make this 12x plus 88 equals 160. We need to get rid of this 88 first. We subtract. That neutralizes it. We have to subtract 88 on the opposite side in order to respect the integrity of that equal sign. You cannot subtract 8 from 0, so we change that to a 5. That becomes a 10. And we end up with 72. 12x equals 72. Now we divide both sides by 12. And we get x equals 6. So that is the number of flower beds that he planted. Next one, another word problem. We're going to stay organized. We're going to convert words to math. Okay. Jen earns $40 per day at a restaurant. Here we go. $40 per one day. Now notice, I don't write the name Jen down here because there's only one person. All right, if there was Jen and Matthew, then I would write his name as well. Okay, in addition, she earns tips. If she worked 20 days in the month of July, okay, so here we go, $40 a day times 20 days. The days cancel out. And we have $800 that she's earned just by working and getting $40 per day. In addition, she earns tips. Okay, she earns a total of $925. Okay, so we know the $800 she worked plus the tips is going to give her $925. So that's our equation. The tips becomes the unknown. We don't know how much that is. And look, here it is. How much did she earn in tips? That means tips becomes our x. Ladies and gentlemen, these are the words. How much, how many, whatever follows it, that's going to be your x. So I'm going to take this word tips and I'm going to shrink it and I'm going to put x right next to it. That's going to be our equation. So here we go. It's going to be $800 plus x equals $925. Okay, how do we solve that? Again, if it's easier for you, you could rearrange this and make it x plus 800 equals 925. Okay, all I did was rearrange these two terms, and then it might be a little clearer to you that you need to subtract 800 to isolate x. Subtracting 800 neutralizes that neighbor. We have to do it on the opposite side to maintain that equal sign, and our final answer is going to be x equals $125. So that's how much she earned in tips. This 125 would go right there in place of x, and when you add 800 and 125, you get the total of 925. Next one. Okay. Now we have an inequality. Remember we talked about that during the vocabulary section. So let me write that down. For the most part, you solve inequalities the way you would solve an equality. So if there was an equal sign here, we have 7.5 times x. In order to get rid of this neighbor, we would divide by 7.5. to get our answer. We're going to do the same thing here. Now I want to point out, if you ever have to divide by a negative or multiply by a negative in the process of solving for x, you got to flip that sign. That's not going on here. Here, this is a straightforward division problem without a negative involved. Okay. So let's talk about how to solve this right here. Okay. Remember, first thing I like to do is draw my shoebox, and this guy topples in. Now, we cannot proceed as is because this decimal can't be here. We have to move this decimal to the right once. This is review, I'm sure, for most, if not all of you. And because we move it to the right once there, we move it to the right once here. Okay, so our new shoebox becomes 75 on the outside and 375.000. That's how I like to set up my shoebox. Okay, now what do we do? Okay, whenever I'm dividing like this, I make these numbers smaller. What do I mean by that? Well, we know 75 doesn't go into 37. Well, we know it doesn't go into 3. We know it doesn't go into 37. So how many times does 75 go into 375? So this is how I approach this. I say to myself, I'm going to ignore for a moment this number and this number. And I'm going to ask myself, how many times does 7 go into 37? And the answer would be 5. So that is the first number that I would try. I would try 5 times 75. And I would do it on the side. I would not try to do it in my head. 5 times 5 is 25, carry the 2. 5 times 7 is 35, plus 2 is 375. So what do you know? We got it on the first shot. Therefore, your final answer is going to be x is greater than 5. So to review, we divided both sides by 7.5. Because we were not dividing by a negative, we kept this greater than sign as is, and we divide 37.5 by 7.5, we get 5. So this would be what you would enter on your piece of paper that you would then submit to me. And again, please label it as number 14. Okay, we have another solve for x. Let's see how we're going to handle this one. We have 4x minus 5 equals 19. Okay, folks, by now, at this point in the video, you should be able to handle this easily. We're going to add 5 to both sides to neutralize that. Your final answer right there. x equals 6. Next one. Okay. Is x equals 7 a solution to this inequality? Let me write it down. Okay. Remember what I told you folks about that x being in the middle? See it right there? It's confusing. Let's clarify what's going on. I'm going to change that to -6 over 7. And I'm going to be very clear that that x belongs in the numerator, like that. Then I'm just going to rewrite the rest of it. Now, is x equals 7 a solution? When you're in a situation like this, everywhere you see an x, you're going to put 7. So what we're going to do is we're going to substitute this 7 everywhere we see x. That's the only place we see it. Okay, so I'm going to rewrite this as -6 over 7 times 7 over 1 minus 6 is less than -1. Now, what do we see here? This is very similar to when we were canceling out units. We have a 7 above and a 7 below and a multiplication sign. That gives us the permission to cancel these 7s and they become 1. So now this is going to get rewritten as -6 over 1, right? These are the two integers that survive that simplification process. Minus 6 is less than -1. Now, folks, we have another situation where I believe it's helpful to use the number line. So let's look at this right here. Okay, let's just look at that. I'm going to rewrite that as -6 minus 6 is less than -1. What is -6 minus 6? Let's go to the number line. Okay, when I do my number line, I always put 0, and I start with the first number. First number is -6. So I'm going to start here. I'm going to call that -6. Now, what's next? You see that negative sign right there? That means I'm going to go this way. How far am I going to go? 6 units. So I'm going to go this way. 6 units, and I'm going to end up there, which is -12. So -6, start at -6. The minus sign means I'm moving to the left, and I'm going 6 units to the left, and I end up at -12. So I'm going to replace this with this. And I'm going to ask myself, is this a true statement? Is -12 less than -1? Okay, there's my -12. I erased it for some reason. Okay, this is how you deal with negatives on a number line. Let me take this away. Okay. Where would -1 be on this number line? Be right here. Right there. So the question is -12 less than -1? The answer is yes. whatever sits to the left is always smaller. So look, what's bigger, 0 or -1? 0's bigger. Would you rather have $0 or -$1? I'd rather have $0 than owe someone $1. Would you rather have -$1 or -$6? -1 is bigger than -6 because it sits to the right. Okay, and that also extends when you move to the positive side of the number line. Okay, I have two numbers over here. I'm going to call this 2, I'm going to call this 4. Which number's bigger? It's 4. Why? Because it sits to the right. What's bigger, 4 or -1? The answer is 4 because it sits to the right. What's bigger, -12 or -6? -6 is bigger because it sits to the right. The fact that we got a true statement, -12 is less than -1, means that x equals 7 is indeed a solution to that inequality. So that question means if we plug in 7 for x, do we get a true statement? And we did. So we would say yes to that. Okay, another word problem. We're going to take our time and we're going to convert words to math. Here we go. Jane goes to the amusement park and is charged a $14 entry fee. Okay, so right there, she's charged $14. Each ride is $3.50. Whenever you see that term each, that means the variable is going to be involved. So each ride tells me that $3.50 is going to be multiplied by something. She has a total of $58 to spend. Okay, so I'm going to put $58 over here. Each ride is $3.50 per one ride. If R equals the total number of rides, If R equals the total number of rides, then true or false? The inequality below explains this accurately. Okay, so here we go. She has a total of $58. That's her budget. Okay, we call that the budget. She can't go above this. So that means the total cost of her day has to be less than or equal to that. It can be equal to 58, but it can't be over. So it's going to be less than or equal. Okay, so let me clean this up a little bit. Here's your $14 fee. Then we're going to add $3.50 for each ride times the number of rides. R rides is less than or equal to $58. Watch, folks, how the units work. Rides cancels out. Dollars survive the cancellation simplification process, and that's what we want because we want our answer in dollars. So this becomes 14 plus 3.50 R is less than or equal to 58. That's exactly what is given. So the answer to that is going to be true. Here we go. Another inequality. Converting words to math. Here we go. True or false? 18 less than twice a number is no more than 98. Okay, look at this. 18 less than twice a number. Here's twice a number. If you subtract 18, it is 18 less than that, and it's no more than 98. Okay, so this is how I like to handle this. There's 2x minus 8. And now I have $98 here, or 98. So I say to myself, okay, this 2x minus 8 can be no more than 98. Right, so in my mind, I might move this around. I say, okay, it can't be more than 98. It can be equal to 98. So therefore, that equal sign there is fine. But it can't be greater than 98. It can't be up there. If it's no more than 98, it can't be up here. It's got to be down below. Therefore, the 2x minus 8 is either less than or equal to 98. That's what no more. Sorry, sometimes I do that. I write off the screen. That's what no more than means. Less than or equal to. Can't be more. Can be less than, can be equal to, cannot be more. So that's a true statement. Okay, let's go to this one. This one is pretty straightforward. I've seen this before in class many times. Let's talk about it. The diameter is 4. What's the circumference? Remember, circumference means distance around the circle, very similar to perimeter of a rectangle or a quadrilateral. The formula for circumference, it's pi times the diameter. They gave us a diameter here of 4 inches, so all we need to do is substitute 3.14 times 4. And when we multiply that out, we're going to get 12.56. And it's going to be in inches, not inches squared. Next one, an area problem. Again, you folks have seen this. Let's get the formula for the area of a circle. Remember, the word area, 2 A's, the units are going to be squared. So we know we're going to have millimeters squared as the answer. Okay, they give us the radius. Therefore, the area is going to be 3.14 times 2 squared, which is 4. And we're going to get the same answer as before, but they're going to be square millimeters because it's area. Next one. Folks, this is pure visualization. Picture cutting this and then opening this up. And what does it look like inside? Well, it's got to be this one. This is the only one that has circles. Okay, and if you envision this, that's what it would look like. I wish there was a better way for me to teach that. Okay, compound or composite figure. Let's talk about how to do this. Best way is for me to redraw it. I apologize for taking your time here. I encourage you to redraw it on your own piece of paper, and just make sure that you get all the measurements correct. I leave off the units. You don't need them. Okay. What is the area of the figure? Okay. In this particular problem, they make it relatively easy because they give you the 11 here. So let's pretend that 11 wasn't there. because the one on your test, you may or may have that benefit. Okay, how do you attack these? You take bigger numbers and make them smaller, and you do that by looking across the street to get information. So here's my first target, this 18 right here. I'm going to try to go after this guy. All right. I look across the street. I see this is 7. That means it's 7 up to here. Right there. This distance right there is 7. So if here to here is 7, I know that because that's what's across the street. Then what's this distance right there? 7 plus this distance had to equal the original 18. So this has to be 11 right there. Once I put the 11 there, I get rid of that 18. Okay, now, do I have enough information to get the area of these two rectangles? Do I have length and width for both of them? I like to label the rectangles with Roman numerals so that you don't get the numbers confused. All right. If I put a 2 here, I might confuse myself that that's the length of that side. So I use Roman numerals just for that reason. Okay. Rectangle, Roman numeral 1, the area is going to be 4 times 7, or 28. Roman numeral 2, 2 times 11 is 22. Total is going to be figure 1, 28, figure 2, 22. Answer's 50. There it is right there. Okay, here we go. Number 23, another supplementary angle. Remember, when you see that word supplementary, you think of supper. You think of a plate. A plate is going to sit on a flat table, and that distance is 180 degrees. So whatever they throw at you, 180 degrees is going to be involved. Okay, so here we go. We have angle A and B are supplementary. Angle A equals 130. Does B equal 25? True or false? So we know A plus B is going to equal 180. They say that A is 130. Then we know B has to be 50 to get to 180. Here, they say B is 25. That means it's a false statement. Okay, here we go. Very similar problem. Here we're dealing with complementary angles. So now 90 degrees becomes involved. A is 48, B is 42. So A plus B has to equal 90. They tell us that A equals 48. Therefore, B has to be 42. That's a true statement. Next one, another composite figure. Okay, let me draw it. Again, I'm off screen. I'll come back as soon as I finish drawing. I appreciate everyone's patience. Again, I don't feel the need to write the units in. This can be a nice rough sketch. This is not the time to be perfectly artistic. You want to be neat. You don't want to have numbers all over the place, but you don't have to be perfect. Okay, so, and always double check. Make sure you got things written down correctly. Make sure you transcribed correctly. Okay, here we go. We go after big numbers and make them small. The biggest number is 9. You go across the street to get your information. How do I make that 9 smaller? Okay. How do I shrink that? Okay. Go across the street. What do you see? You see this is 7. So right up to here, it's 7. If this was 9 in total, and now this is 7 up to here, this has to be 2. The 7 plus the 2 has to equal the original 9. Once we have it, we get rid of this. Do we have enough information to get the areas of these two rectangles? Do we have length and width? The answer is yes. 5 times 7 here is 35. 8 times 2 here is 16. Figure 1 is 35. Figure 2 is 16. We add them together. There's our answer. Let's see if it's there. There it is, right there, first choice. Another composite figure. I apologize for taking the time to draw this again. Double check that you got the right numbers. I always do. 6, 2, 11. Okay. Biggest number. Can we make that smaller? Go across the street. 16. So up till here it's 16. Oops. Right there is 16. I'm going to cross this out. Change that to 16 and that to 2. Together, they equal the original 18. Do we have enough for the two rectangles? Roman numeral 1 is going to be 2 times 11, which is 22. Roman numeral 2 is going to be 16 times 5. Folks, let me show you how I multiply 16 times 5 in my head. I go this way. And I say 5 times 10 is 50. And then 5 times 6 is 30. And you get 80. That's how I multiply one integer times two integers. I go this way. Okay, so there's our answer, 102. Let's hope there's not another composite figure. Okay, here's a number line, very important in math. You have to be facile with the number line. Recall, open circle means it does not include that number. It comes very close, but it doesn't include it. So right away, I know that my inequality is not going to be, it's not going to have equal sign underneath. I know that. It's got to be without it. Okay, they ask you to write this one. Okay, so here we go. This region here is greater than 6. How do we know? Because it's to the right. Remember in the last video, whatever sits to the right is greater. So this is depicting that x is greater than 6, not equal, greater than 6. So this is what you would write in for your test. Next one. Which is equivalent to negative 14x plus 63? Okay. So basically they're asking you to go in reverse now. Normally when we distribute, we get the arrows going and we get a binomial expression like this. Here they want you to go backwards. So what I would do in this scenario is I would just try each of them out. Okay, let's try the first one. Let's do them together. Okay, we get our arrows popping. We always circle the sign and the second term. White arrow. Okay, the white arrow says -7 times 2x. That's going to be -14x. Then we have -7 times -9. -7 times -9. That's the yellow arrow. Whenever you have a negative times a negative, you get a positive, and 7 times 9 is 63. That matches what's in the stem of this question, therefore that's your answer. No need to do these. 29. The dashed line is known as the line of symmetry. That is correct. The figure's exactly the same on both sides. That's what symmetry means. Next one. The line beneath the 5 centimeter mark is known as goes all the way across, that's the diameter. Solve for x. We're almost done, folks. (3x plus 3) equals 30. We're going to subtract 3 on both sides. 3x equals 27. And I know you could do that in your head, but just to keep the protocol correct, we divide by 3. We can cancel those because the same thing on the bottom as it is on the top, and there's multiplication sign, and this equals 9. Last one, the figure below. Folks, this is a rhombus. Remember, the word rhombare in Latin means to spin. This thing wants to spin like a dreidel. It has all 4 sides equal. Looks like a diamond. That's a rhombus.